Okay, I am going to go over the Unit 5 review. This is graphing trig. Let's start off with problem number 1. Okay, so one thing that's a little bit weird about this, if you don't like it, this is typically our K, so you can move this over here if you wish, or just leave it where it is. So I always start off with my center line. So down 1. Okay, from there I do my amplitudes, 4. So I'm going to go up 4, down 4. 1, 2, 3, 4. Down, 1, 2, 3, 4. Make sure it's visually centered. Okay, then I need my period. So it's 2 pi over b. B just happens to be 2 in this scenario. So my period is pi. Go ahead and make some vertical lines at pi. And you'll notice I can fit 2 cycles in this one. Now, cosine. Okay. I did have to determine, does it start in the middle or top? Cosine starts in the middle. And it's going to go 1 down, 1 up, and end in that cycle. Okay, and it's all about splitting in halves and quarters. So I know at the halfway mark I should be at the bottom, quarter-way mark, midpoint. Boom, boom, repeat, doom. Okay, go ahead and plot your graph. So you should get something that looks like this. Nice smooth curves. And this would go forever in both directions. Okay, next one. I might rewrite this one. So y equals, I'm cool with that. I like the period here. I'm okay with the word sine. I don't really like that theta is with that 2. So I'm going to go ahead and pull the 2 out. Now, what I recommend doing is graphing this right now, and we'll come back and worry about this horizontal shift here in a minute, okay? So there's no k value, no vertical shift. So I'll go ahead and put my line through the middle. I'll do my amplitude line, so up 3, down 3. Okay, just like last time, it's 2 pi over 2, which is just pi. So there's my period. And so I can fit 2 cycles here. Now, what would this look like without the shift? Now, this is a sine graph. Sine starts in the middle, 1 up, middle, bottom, boom. And I just repeat the process. You can just leave the dots if you wish, or you can go ahead and show what it would look like without the shift with the dash line. I like dash lines because it's really not part of my answer, but I need it. And you get something that looks like this. Okay, how do I find my shift? The easiest way is set all this equal to 0. So I would say 2 theta minus pi over 2 equals 0. I'm going to go ahead and add this to both sides. I get 2 theta equals pi over 2. I'm going to divide both sides by 2. This goes away. I'll change this into a fraction. And now I'm going to multiply by its reciprocal. And I get pi over 4. So I'm going to go ahead and put a pi over 4 here. And I'm going to check just distributing. I check. If I distribute, would I get this? Yes. If I distribute and put a 2 right here, would this reduce to 1/2? And the answer is yes. So that tells me I'm going to shift every dot up here, okay, to the right pi over 4. And in this particular graph, it just happens to be one box. So right, 1, boom, 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 boom. And now I'm off my grid. Don't be afraid to go backwards. Okay, so here is what my graph would look like. So the shift would go like this, and you can see my snaking graph. And then if I went back to the y-axis, it would look like this. Okay, cosecant goes with cosine. Okay, so I'm going to graph this like this is a cosine graph. So let's start off with our k. That's right here. So I'll go +2. Then I do my amplitudes. My amplitude is 2. A lot of 2's in this problem. So I'll go up 2 and down 2. Okay, next I'm going to do my period. Now, if I pulled this off, it would be 1/2 beta. So 2 pi over 1/2. I'm going to multiply by its reciprocal, and I get 4 pi. And so I'm going to get something that looks like this. I'm going to do this kind of faint, and I think I might do it in a green line. Okay, go ahead and graph cosine. So cosine would look like this. Boom, boom, boom. I want 1 up and 1 down. Okay. And then it splits nicely in quarters, and I get something that looks like this. So if I were to graph this in the center here, get a dashed line again, you get something that goes like this, and like that. Okay, these center points are super important. That's important, that's important, that's important. Everywhere I see those center lines, I make vertical asymptotes. So vertical asymptote there, there, and there. And then it's all about flipping the U's here. Okay, so I notice I kind of have like an upside down U. If I flip it, I get something that looks like this. And there's my graph. I'm going to flip a U here, make sure it goes all the way up and touches that point. Make sure it brushes through the vertical asymptotes. And last but not least, boom, off my grid. Okay, now let's go over to tangent and cotangent. I'm probably going to determine the period first for this one. So tangent and cotangent have a different formula. It's pi over b. And so this one's just pi over 2. Now a cotangent graph, next thing I focus on is my y-axis. Cotangent graphs have vertical asymptotes here. Tangent graphs have a dot here. So cotangent graphs are a little bit easier. Okay, so I'm going to have vertical asymptote here, and then every pi over 2. And what I like about cotangent is you can visually see that first one. Okay, now when I go to plot my points, there is a vertical shift out here. Again, sometimes we see it on this side. So I'm going to go, normally it would be right here in the center, but I'm going to shift it up 1. And I'll do this all the way down for all my graphs. And cotangent graphs go downhill. So I'm going to go to the halfway to the left and up, halfway to the right and down. So you're going to have dots that look like this. And it's always up 1 and down 1, up 1, down 1, up 1, down 1. Technically, I'd probably have one like right here and right here. Okay, now go ahead and connect the dots, brush up against the asymptotes, and you're going to have a bunch of graphs that look like this. A lot of cycles in this one. Okay, tangent. You'll notice my graph is centered a little bit, so that makes life a little bit easier. Kind of dead giveaway what's going to happen here. I would start by finding my b, so pi over 1/3 multiplied by its reciprocal. So my period is 3 pi. Now, I'm not going to go out this direction, 3 pi. I'm going to split that in half. I'm going to go 1.5 to the left, 1.5 to the right. Okay, I want this to be centered along the y-axis, but the total distance has to be 3 pi. So the distance between these two asymptotes is 3 pi. Okay, now my points. Normally I'd be right here, but this tells me to shift down 2. And I'm going to go right halfway and up, right halfway and down, because I want this thing to increase. Boom. And technically I'd have one over here, and I'd have one here, and my graphs are going to look like this. I don't have much room to get more than this middle one in. Brush up against the asymptotes, And this would probably be like that. This would be like this, and I'm going to run out of graph. Okay, we did this one in class. Okay, I'm just filling in all the ratios. This is kind of a memory thing. We had a little trick in class that we worked through together. So I'd put my angles here, 0, 30, 45, 60, 90. And then I'm going to put my radians here, 0, pi over 6, pi over 4, pi over 3, pi over 2. And then I would just start plotting some point. I know this point is 1, 0. I know this point over here is 0, 1 right here. I do have to know that this is cosine, this is sine, and the outside is tangent. And another little side note, tangent is equal to sine over cosine. Now, here's my little trick to fill this out. I'll just do one with you and let you do the rest. So a big square root, it's going to be sine on the left, cosine on the right, all divided by 2. And I'm going to start out low, 0, 1, 2, 3, 4, and go high, and then I go reverse. 4, I forgot the 3. 3, 2, 1, 0. Now up above, I don't care if you have angle, degrees, or radians. 0, 30, 45, 60, and 90. So let me just do one of these with you. Maybe I'll do 30 degrees, okay? So if I wanted to find cosine, because that comes first. Okay, I go to cosine, 30 degrees. So I'm in the second row, second column. And my answer here would be square root of 3 over 2. So that goes right here. Square root of 3 over 2. Okay, if I wanted to do sine, I'm going to go up a row. Square root of 1 over 2. Well, the square root of 1 is 1, and I get 1/2. If I want to do tangent, I ignore this. Tangent, I could care less about the dividing by 2. I just focus with sine and cosine. And for tangent, I would get square root of 1 over square root of 3. Well, the square root of 1 is 1. And I'm not allowed to leave radicals on the bottom, so we rationalize the denominator. And my final answer here is going to be square root of 3 over square root of 9. The square root of 9 is 3 over 3. Okay, and I can just do that and work my way all the way around the unit circle and get those other ratios. Okay, last problem. Ferris wheel. Step 1, draw a picture. Always helps to draw a picture. So I've got my diameter here. This thing's going to be a little bit off the ground, so I got something that looks like this. I'm going to do my equation and make my graph at the same time. So some important information. There's my diameter. Here's my revolutions per minute. That's going to help me find the period and my B. I also got this 2 feet above the ground. So I'm going to start with that, 2 feet above the ground. I also want a center line. Now, my diameter is going to help me find my radii, because really my radii are the most important. So if the diameter is 36, this has to be 18 and 18. And I also need to know my center line, like where does this occur? And in this particular problem, why did I draw it that way? Those arrows look crazy. Let's go down architecturally there. That's better. I just get 18 plus 2, so 20. Okay, so let's start plotting our graph. So I know my center line here is going to be at 20. Okay, from that center line, I'm going to go up 18 and down 18, and those are my amplitudes. So up 18 is 38, and down 18 is 2, and look how convenient that is. Fits perfectly. So I'm going to start making my equation. I don't care if you do h of t or y equals. Maybe I'll just do y equals because I'm going to do that in a calculator. I do know the shape of this thing, okay? I know that it's going to be something like this, where I go up and I go down. That's one full cycle around a Ferris wheel for height. And that graph is negative cosine, flipped cosine. So I know it's got to be negative. I know it's going to be a cosine graph. Whoops, I better throw my amplitudes in there. So 18 goes here. Now on my calculator, it's going to force some parentheses, so I'll put parentheses right there. Okay, I do need to have a variable, so the calculator is going to put x. If I was doing this story problem, I'd probably plug in a t, and then I've got my plus 20 on the outside. Okay, here comes this 3 revolutions per minute. 3 revolutions per 1 minute, but I'm going to change that to 60 seconds because my graph is in seconds. Now, I don't care about 3 laps around the unit circle. 1, 2, 3, okay? I care about 1, starting at the bottom, 1 up, and 1 down, so I can make my graph. So I want 1 revolution. Now, this is a pretty easy one, because I can just reduce this, but if it's not an easy one, if it's an ugly number, just cross multiply. I get 3 times x equals 60, and when I divide, I get x equals 20. Okay, so I'm going to make some, my period here at 20. I could do my graph right now. I know I'm going to start at 2. 20 splits nicely into quarters, so at 5, I'm at the halfway mark. At 10, I'm at the top. At 15, halfway, 20 at the bottom. And I'll just repeat, and I can fit 1.5 cycles on this graph. So let me go ahead and graph it. It's going to look like this: up, down, down, connect, up, and boom. There's my graph. Okay, I do need to figure out B. Here's the big mistake. Don't just put 20 right here. That's the period. The period does not go in my equation. B goes into my equation. Okay, so I need to figure out what goes here that creates 20. Now, you'll remember there's a formula for period. Okay, it's 2 pi over B. And when does that equal 20? Let's do some basic algebra. I don't like B being in the denominator, so I'll multiply both sides by B. That goes away. I get 2 pi equals 20 times B. Now it is a one-step algebra equation. Divide both sides by 20. This goes away. I get B equals, I can reduce this. This does reduce to 1/10, so pi over 10. All right, I'm going to go ahead and plug that in up here. Pi over 10. Now it's a calculator problem. So step 1 on your calculator, Desmos, or on my special calculator here, you got to make sure you're in the right mode. I need to be in radian modes. Okay, the pi up there is a dead giveaway. I'm in radians. And I'll go ahead and get out of here now. We go to y equals. I like y equals better than just plugging my numbers in, 12 and 17, because I can verify that my equation's right. So negative 18 cosine. There's those parentheses I was talking about. Use the pi button. Divided by 10 times x. I don't even need to put multiplication. It'll know to do that. Close my parentheses, plus 20. Now, when I look at a table here, let me make sure I start at 0. I am going to. I can verify. Does it start at 2? And it does. Okay, as I'm rolling through, at 5, I'm at the midway mark, yes. At 10, am I at the peak? Yes, okay. At 15, am I back to midway? And at 20, am I back down to the bottom? And I am. Now, I can go up here and determine, okay, at 12, there's one of my answers. And at 17, there's another. It says round to the nearest hundredth, that's 2 decimal places. So this answer would be 34 point, let's say 56. And this one is at 17, 9.42. And hopefully that helps you and you're all ready to go for the graphing trig test.